Now something in yellow. Okay, yellow. Just joking. So there's one feature if you look at maps. Okay. If you look at vertical transects, so if you take the ocean and you cut it like a cake and you open the cake and you have a look at it from the side, it is impossible to show maps which have the same vertical and horizontal scales. So what's often done is that the horizontal scales are distorted. They are so compressed that you can see the entire distribution in an image. Okay, and I'll show you here on the left side. There are two examples of so-called scale distortions. Okay, one example is you actually cut across the mid-Atlantic ridge system. This, what's shown here is the water depth. But the horizontal axis is 180 times compressed compared to the vertical scale. Okay, so if you wanted to do it a little bit better or more realistic, it's not better, I mean more realistic, you would do something which is shown here in the bottom panel, okay, where the horizontal scale is compressed by 30 times compared with the vertical scale. So if you really wanted to do it absolutely realistic, you would actually only show a very tiny film of water sitting, or of oceans sitting on the earth, on the upper, on the continental plates, but you couldn't identify any distributions anymore. You couldn't see anymore. So what it tells you is that actually the ocean, and similarly the atmosphere actually, there are very, very thin layers compared to the vast horizontal distances that we're dealing with.